Last week, scientists at NASA released this. The shot is compiled from data from NASA's VEERS instrument, which orbits the Earth about every 100 minutes, taking measurements of light coming off the planet. That can be translated into ribbons of imagery like this, and then into one of these. And this is just the latest in NASA's Earth from Space album, which may be one of the most mind-expanding collections of images in human history, in my opinion. It began with a shot taken by the Apollo 8 crew in 1968. And NASA scientist Gene Feldman says it made a big impression on him.
I think it's called Earthrise. And I remember seeing that and the stark contrast between this gray, lifeless rock that we had spent all this time and effort getting to. And here was this beautiful little shining blue and white marble that held everything that we as humans know about history, art, culture, love. Everything was contained on this one little tiny dot in space. I was just so fascinated by the beauty of it and trying to understand, how did this happen? How does it work? Has kind of led me to do what I've done.
And for the last several decades, Feldman has done remote sensing.
Yeah, there's an old expression about sometimes you can't see the forest for the trees.
That is not a problem for a remote sensing scientist. Feldman studies the Earth from space. He says it's like taking vital signs of the planet, which means working with
scientific images that maybe show ocean color or sea surface temperature or land vegetation, or those are why we do what we do, to tell us about the planet from a clinical perspective. But the other images, the beautiful ones, they resonate with people because it's our home.
In 1972, we saw our home in a new way. Apollo 17 astronauts snapped this picture. Actually, they snapped a lot of pictures.
It crystallized so much about the environmental movement at the time. It gave people the first look at their home planet as a single entity.
In 1990, Carl Sagan made this Voyager image famous, his pale blue dot. Here he is on Science Friday talking about it.
I thought, that's us, a mote of dust in a sunbeam. And it spoke to me about the need for us to care for one another and also to preserve the pale blue dot, which is the only home we've ever known. And it underscored the tininess, the comparative insignificance of our world and ourselves.
Then in 2002, Blue Marble 2.0, NASA's Rob Simmon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simmon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the Moderate Resolution Imaging Spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command-Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it.
With satellite data, like this map of chlorophyll and land vegetation over time, accuracy is key, obviously, but it's also most easily deciphered as imagery, Feldman says.
Because the data volumes that we get from space now are astronomical, the only way that we can really handle this anymore is to visualize it. And no matter what computers we may build, the human mind and the human eye, in my mind, is still the most powerful integrator of information.
The objective here is to create models that accurately reflect the past so that we can predict how the planet will change in the future, Feldman says.
Or if some of those changes might be negative to the way we want our Earth to be, what can we do about it?
Simmon wants to make the world better too, starting with the atmosphere.
And I'm getting results that I like, but I think it's a little bit exaggerated. So I'm working on some techniques to try to tone it down a little bit.
To make it a little more homey. For Science Friday, I'm Flora Lichtman.